In this session, I'll give a live demo on internal incompressible CFD analysis of ducted fan by using SimScale software. To open SimScale software, open browser or Microsoft Edge and search for the web address simscale.com. Next, go to Dashboard. To create new project, click on New Project. Enter the project title. I'll give it as ducted fan. Describe your project. Internal CFD analysis. And select category as aerospace and create project. First step is to import geometry required for the analysis. To import geometry, click on the plus icon in geometries. Click on import from computer. Select your geometry file from your computer. To import, click on import. This is the fan geometry, which is imported in the SimScale software. Next, we will create a domain for this fan. We will create domain by using enclosure function. For that, right click on ducted fan, go to add geometry operation. So you have your enclosure operation here. Click on enclosure. Here you need to input your dimensions for your domain. Next, click on Start. Domain is created. Select surfaces. So the domain is created for our ducted fan. This completes the pre-processing step. The next step is solver execution step. Next, we shall move to solver execution step by creating simulation. To create simulation, click on Simulations, select Incompressible and click on Create Simulation. The turbulence model will be K omega SST and time dependency will be steady state. Save it. Next, assign materials. For that, in materials, click on the plus icon, select air and apply. I'll keep the same default values of air here. Save it. In initial conditions, keep the same default values. Next, assign boundary conditions. First, select velocity inlet. Here you need to enter the inlet velocity. As you can see here in this problem, the air is flowing along z-axis. So enter the value of uz here. So I'll give minus 20 meter per second inlet velocity, minus because here you can see the air enters through this space and it flows through the negative of z-axis and exit from this space. So the inlet velocity will be negative. Select the inlet phase. This will be the inlet phase and save it. Next, apply pressure outlet. The gauge pressure, I'll keep 0 Pascal and assign the outlet phase. Select the outlet phase and save it. Next, in advanced concepts, I'll keep the same values in numerics. Save. Simulation control, keep the same default values. Save it. Next, we shall generate mesh. For that, click on Generate. Mesh is generated over the domain. Hide the domain. After the mesh is generated, next step is to run the simulation. To run the simulation, click on Simulation Runs. The simulation duration is 36 to 54 minutes. Click on Start. The simulation is completed. With this, the second step, that is solver execution step, also completes. The last step in analysis is post-processing step. To analyze pressure and velocity magnitude counter plots, click on Post-Process Results. In Parts Color, select Pressure, hide the domain, This is the pressure counter plot of the fan. Next, to view the velocity magnitude counter plot, add cutting plane. Select translucent surfaces with wireframe. I'll keep the orientation X. Velocity magnitude counter plot of the ducted fan. You can also analyze the streamlines over the ducted fan. For that, add particle trace, disable cutting plane. I'll increase the horizontal seats to 20. Hide the domain. In parts color, select solid color. You can also animate the streamlines. To add animation, go to animation, select particle trace,